This video is about how Newton's second law can be applied to a connected system. We're looking at RE3.2 Newton's second law's discussion question number 10. So for part A, we are to find the resultant force acting on the two-block system. So we look at the two boxes as though as they are one big 6 kilogram system. We ask ourselves the two questions. Number one, what are the driving forces to make the system move? So there is a 60 Newton pulling force to make the whole system move towards the right. Second question, what are the opposing forces to prevent the system from moving towards the right? So as you can see in the question, there are frictional forces. So the total frictional forces is 9 plus 7, that's a 16 Newton frictional force. And hence, the net force on this system is 60 Newton with a negative 16 Newton. We must remember to define a direction to be positive. So I'll take right to be positive. And we'll get 44 Newton as the net force on the system. Now for part B, what is the acceleration of the system? So we apply Newton's second law on this 6 kg system. The net force equals to mass times acceleration, and acceleration is simply just the net force divided by total mass, and we will get 44 divided by 6 kg, and this should get you 7.3 meter per second square for part B. In part C, you have to find the force exerted on the 2 kg block by the rope. So let us draw a FBD of the 2 kg block with this tension force being our objective. Okay, a frictional force that is applied on this box is 7 Newton. And again, we will apply Newton's second law on this 2 kg block, and net force equals to MA. Net force is tension plus, because net force is adding up all the forces, so tension plus a negative 7 Newton. Mass is 2 kg. Acceleration is the same value as found in part B. Now, the acceleration of the whole system must apply to the acceleration of the individual pieces within the system. This is so because otherwise the rope will break. We didn't see that happen, so therefore every item, every box in this system must move with the same acceleration. So if you solve this, you will get a tension force of 21.7 Newton, which I'll write to 2 SF. Alright, so now for part D. Part D is a question to convince you that the individual acceleration of the boxes must be the same as what you have found in part B, the acceleration of the whole system. So if we just look at Newton's second law, or rather we apply Newton's second law on the 4 kg system, and we quickly sketch out the FBD for 4 kg box. 60 Newton pulling force. We have a frictional force of 9 Newton. There is a tension force of 22 Newton as found previously. Now these two tension forces, this tension force and this tension force on the other box must be the same, for the same reason, because if the tension force in the rope is different, then the rope would either be slack or it will be broken. Alright, we didn't see that, hence usually the tension force in the rope is the same, is of the same value. Okay, so back to Newton's second law on this 4 kg bigger box. Net force is mass times acceleration, and my net force over here, I get a 60 Newton. I add a frictional force to it, I also add a tension force to calculate the overall net force on the 4 kg block, and this should give me a mass of 4.0 kg multiplied by the acceleration. So if you solve all this, you will be able to get that the acceleration value is again 7.3 meter per second squared. For more videos like this, do subscribe to the NJC GH Science channels. Your teachers will be creating a lot more concept videos to help you in your revision.